Hello everyone, my name is Kathy Loughlin and this is my colleague Simon McKee from the Operational Excellence team at InvestNI. Thank you for participating on our SMED webinar today. The presentation video will run for around 26 minutes and then we'll move on to our Q&A session. If you would like to submit a question for Simon, please do so using the chat function. Thank you.
Welcome. Hi, my name is Simon McKee. I'm an Operational Excellence coach with Invest Northern Ireland. Today we're going to discuss single minute exchange of dies, or the SMED system, a revolutionary way to reduce changeover times on your production lines. You might notice that changeover times in your production lines differ by operator, shift, customer, or even product. If so, we need to simplify and standardize changeover times and reduce their overall length. SMED is a powerful tool to make that happen. By the end of this short presentation, you'll be able to explain the concept of SMED and describe the process steps for applying SMED. We'll cover the following topics today. What is SMED? Applying SMED in your processes, and how Invest Northern Ireland's Operational Excellence Solutions team can help you. So, what is the SMED system? The SMED system is the brainchild of Seigo Shingo, a Japanese industrial engineer and world-leading expert on manufacturing practices. He passed away in 1990. While working for the Toyota Motor Corporation, Shingo recognized that changeover times are a form of waste. He used process analysis and planning to reduce changeover times on the company's production lines to less than 10 minutes. The goal is reflected in SMED's name, single-digit minutes. It took Shingo over 19 years to develop the SMED system, but his pioneering work has saved manufacturers far more time and work hours. Companies that have applied SMED have documented changeover time reductions averaging 94%. In practice, it may not always be possible to reduce changeover times to less than 10 minutes. Nevertheless, applying these principles is sure to slash changeover times in your operations. A good example, Formula One pit stops offer a vivid illustration of the improvements that SMED can deliver. In 1950, pit stops regularly exceeded 4 minutes. Today, they can be as short as 1.82 seconds. Of course, there are big differences in the rules and technology. The pit stop crew in Indianapolis in 1950 were limited to 4 people, including the driver. They worked with mallets to release the wheels and had to clean the windscreen in the absence of a full-face driver's helmet. Today, a pit stop crew can number up to 20 people, using pneumatic tools to remove the tires. All the same, there are a lot of other differences in the process. The crew is in place with equipment ready long before the vehicle arrives. They work on many tasks simultaneously, and the key to this efficiency is the setup operation. The benefits of SMED go beyond save time. They include increased safety through the development of standard procedures for completing the process changeover. Productivity is improved due to wasted time reduction. Customer satisfaction goes up due to achieving shorter lead times. Profitability therefore improves due to increased productivity. Flexibility to be able to respond very quickly to changing market demands. You need to be able to produce smaller lot sizes in an economical way. The organization in general benefits from all of the above. So other benefits of SMED. We'll have decreased defects, decreased late deliveries, and we will have decreased the unused inventory that's lying about the floor, taking up space and costing money. So Shingo focused on the setup operation, the time it takes to change a piece of equipment from the last piece of a production lot to the first good piece of the next production lot. He recognized that the setup operations have two elements, an internal element and an external element. The internal element of a setup operation are the actions that can be performed only while the machine or workstation is turned off and production is stopped. For example, changing the chuck jaws on a CNC lathe machine. By shifting as many internal setup operations as possible to external, changeover times can be drastically reduced, while machines can remain in operation longer, subsequently increasing capacity. The external setup, this kind of setup can be done while the machine is still running. For example, bolts to attach to the die can be assembled and sorted while the press is still operating. A bad example I have observed while videoing a SMED process, when the machine had stopped production, it took the technician 24 minutes to locate the glue bar from an extremely unorganized store. This is all lost capacity. If the glue bar had been at hand, it would have reduced the setup time significantly. Shingo identified 4 basic steps to a setup operation. The first, preparation. Second, installing and removing tooling and parts. Third, measurements, settings, and calibrations. And the fourth, and potentially always the longest, trial runs and adjustments. The preparation step can take up to 30% of the time required for a set operation before any of the process improvements are made. This step involves locating parts, tools and fixtures, and ensuring they're in place. Checking each to make sure they are in working order, and cleaning the machinery and work area. In a traditional setup, parts of the preparation step are done after the machine has stopped. These are non-value added activities and should be performed when the machine is still running. Value is only added when the machine is producing good parts. We'll begin our discussion on applying SMED by focusing on the preparation step in just a moment. Once the workplace is prepared, your operators must remove the tooling and parts from the previous production run, locate the tooling and parts for the next, and then installing them onto the machinery. This can take as much as 5% of the setup operation. Generally, the machine must be stopped to do this, so it is an internal setup. Notice from the diagram, this step takes very little time compared to the other steps. This step refers to all the measurements and calibrations that must be made in order to perform a production run, such as centering, dimensioning, measuring temperature, or even pressure. Although the equipment must often be stopped for this step, the SMED system teaches ways to do these tasks quickly by preparing while the equipment is still running. Finally, the new production run requires a trial run to ensure the calibration has been successful. This involves producing test pieces, inspecting these pieces for quality, and making any necessary adjustments to the machinery. This step is often the longest, taking up to 50% of the setup operation time. SMED aims to eliminate these trial runs so that your production line produces high quality output at the startup. A key point here, the more accurate your measurements and calibrations are in the previous step, the easier the adjustments will be. In a traditional setup, the machine is not making good products until this step is finished. So it's considered part of the internal setup. SMED teaches ways to eliminate this step completely so that the machine makes good products right after it has started up. Each of these steps represent an opportunity to intervene in the production process, rationalize actions, and ultimately, and most importantly, save time. When you come to applying SMED on your production lines, remember that there are two broad categories for improvement. There's the human factor, where preparation and organization on the part of your operators can bring big gains. And then there's the technical factors, where engineered solutions can help you save time. Typically, human factors are cheaper and faster to change than technical ones. You might be tempted to focus on technical factors, but focus first on the human ones. The graph shows where you can make the biggest gains. As discussed, human, achieved through preparation and organization, takes less time and effort to implement and could reduce the setup by as much as 60%. The technical, achieved through engineering and optimization, takes longer to implement and can cost considerably more for limited gains. Applying SMED. How do we apply SMED to our production lines? Here's a generic example of how you might organize a SMED process. Time horizons will differ between operations, but a 4-week process is reasonable in most contexts. We will look at each of these stages in turn, but let's just point out a few important features. First, measurement and analysis are key to a successful SMED process. At each stage, you should benchmark how your production line is currently performing and then examine how your interventions have improved the performance. Second, recording your new work procedures in a standardized work document is critical. This ensures that you capture the changes you've made at each stage so that they can be followed in the future. This guards against a regression into old work habits. Pre-SMED. Initially, we need to define and measure the stages within our production line. Work with a team member who performs a setup operation. Obviously, they know it best. So it's critical that you discover the issues from their perspective. Keep in mind, simply observing your colleagues may temporarily improve changes over time, a phenomenon known as the Hawthorne effect. Record their work sequence, measure the time it takes to perform each element, external and internal, and take note of the distances they travel to perform each task. 3 important tools that are used in collecting data are the stopwatch, the camcorder, and the camera. While you're defining each setup operation, keep an eye out for the 8 wastes. You can remember them using the mnemonic Tim Woods. So, T for transportation. Transportation waste occurs when an operative must leave their workstation to track down the things they need for their job. They might be locating tools, looking for fixtures and fittings, or clarifying order details. The specifics will depend on the operation. In any case, these are things the operative could have already at hand. I for inventory. Are your operatives holding on to excess stock in case of contingency, or producing extra output without a specific order? There may be good procedural reasons for them to do so, but they are almost certainly a target for rationalization. The define stage is the place to find out why this extra stock is being produced and how you might change procedures to reduce it. M for motion. Each action your operatives perform takes time that could otherwise be used in producing good parts. Some actions may even put their health and well-being at risk. The define stage is a good time to map out the movements your operators perform and establish procedural changes that can remove some of this waste. W for waiting. You might find that your operators often spend time waiting for information, such as orders, tools, and material to arrive. Note each occasion when they are left waiting during the define stage. O for overprocessing. You may find that your operatives are doing more work than is strictly necessary and thereby holding up the production line. A common cause is checking that tools are on working order. Keep a note of this at the define stage. O for overproduction. Your operatives should only be producing output in response to an order, but some may try to get ahead of anticipated demand. D for defects. Ideally, all your input material is transformed into output through your production line. Unfortunately, this is almost never the case. There will be offcuts, scrap material, items that must be reworked, and the unused output from trial runs and adjustments. Even so, there is plenty of scope to reduce this waste, so keep a tally of it throughout the define stage. The last is skills and unused creativity. Your operators are the best place to recognize where waste is being created. Make sure you consult them extensively in the define stage and throughout the SMED process. Improve stage 1. Once you've defined the external and internal elements within your production line, it's time to begin improving their performance. The first step is to separate the internal and external elements. Remember, internal elements are setup operations that can only be performed when the machine is not running. External elements can be performed when the machine is running. You'll be surprised by how effective separating internal and external elements can be. It can result in setup time reductions of up to 35% at little additional cost. Here's a look at how you can realize setup time improvements just by separating internal and external elements. This infographic represents a production line before the define stage. We don't yet know if each operation element is internal or external. These are all done when the machine is down. Through definition, measurement, and analysis, we can discover which element can be performed while the machine is running and which must be performed when it's not. We can then rationalize each element. External elements of a setup operation are performed while the machine is running. Only internal elements are performed when it's stopped. The result, save time. Some opportunities to convert internal elements to external ones include rationalizing transportation, using checklists as part of the standard work, performing functional checks and autonomous maintenance. Improve stage 2. With a little adaptation, some internal elements can be performed as external ones. Let's look at how you might identify and modify these. Naturally, the opportunities for converting internal elements to external ones will differ between production lines. Nevertheless, here are some common opportunities for intervention when simplifying your process. Preparing operating conditions in advance. Standardizing essential functions. Using intermediary jigs. Centering and preheating elements. With your team, examine the setup operation for internal elements that might, with some modification, be performed externally. Prioritize the target internal elements by assessing the cost as measured by the materials and labour needed to make the necessary changes, and the benefit as measured by the time that will be eliminated from the changeover. Once you've identified some appropriate internal elements, add them to your external workflows. It may take some careful consideration to develop ways to perform these internal elements externally. Make sure you include the new production procedures in your standardized work documents. We looked at some specific examples earlier, but here are some broad techniques for converting internal elements to external ones. Advanced preparation, jigs, modularize the setup, and modify as necessary. So advanced preparation. Make sure that all the parts are ready in advance of any operation. For example, you can preheat dies in advance of a changeover. Use duplicate jigs. You can perform alignment and other adjustments in advance of the changeover. Modularize equipment, for example. You might replace a printer instead of adjusting the printer head. The printer can be configured for a new part number in advance of the changeover. Modify equipment, for example. You might add guarding to enable safe cleaning while the process is running. So into improve stage 3. Now that you've made the appropriate internal elements external, you can optimize the entire process. This is an opportunity to improve the internal elements to reduce the downtime for the machine setup. You can also rationalize external elements to reduce the non-value-added activities that your operators must perform. You'll find that the overall runtime decreases as you improve each element. Once you've rationalized each element, you should discover significant time savings over your initial baseline. Into the control phase, secure your newfound time savings by embedding the new process in your standard work instructions. This is a vital step. I would also add that auditing against your standard work is another good way to make sure that those procedures and the variation in the way the changeovers are being done are controlled. Okay, we'll have a look at a SMED example. In the first phase, this business identified each of the stages on the line, recording the tools, time, and operator condition for each. This formed the baseline for any improvements. In the second phase, the business identified which of the set operations they could be converted from internal to external. According to the above collected data, we can make out that the machine is idle for 151 seconds during setup. This is lost capacity. Worker is idle for 188 seconds during the runtime, lost opportunity to get ready for the next setup. In the third phase, the business rearranged the setup operations to ensure that only external operations were performed while the machinery was running. In the fourth week, the business streamlined each of the setup operations to realize even greater time savings. They ensured that all the processes were recorded in addition of the standardized work document. So, comparison between before SMED and after SMED. After the SMED technique was applied to the bottleneck operation, the total time taken to perform the operation was decreased by 25% from 339 seconds to 256 seconds. The number of components increased from 198 to 258 per day, and a number of components per month increased from 4,950 to 6,450. You can see from the table that 70 seconds was removed with the introduction of pallet change between run A and run B, a very simple but effective solution. Okay, so that sort of finishes me going through the SMED process. So to get the support you need to implement SMED in your business, Invest NI's Operational Excellence Solution Team is a group of dedicated coaches with real-world business experience. This team can help you with your SMED program. We can help you implement a wide range of initiatives to improve your business's productivity, profitability, and competitiveness. We offer tailored training support, mentoring and coaching. We'll help you promote best practice in your organization, build your capabilities, and ultimately deliver measurable improvements. Get in touch at opexquery@investni.com. Thank you very much for your time, and we hope to hear from you soon.
Okay, thanks, Simon. Before we move on to our Q&A session, there will be an evaluation question on screen. We'd appreciate if you take the time to answer this question to provide us with some feedback. Okay, Simon, our first question today is, what is the best way to run a SMED quick changeover event?
Good question, Kathy. I've been running SMED workshops on site with companies now, I would say, for approximately 8 years. And there's two main ways that they're done. As outlined on the presentation, you can do it on a stage over 4 weeks or over 8 weeks, whichever suits the business. Now, that works quite well, but you find sometimes that it loses a wee bit of momentum and you don't get everybody there for every single workshop. The most effective and efficient way I have done it is a 2-day Kaizen Blitz. So you have all the key people there, the decision makers, the people that can help make the decisions, and the people that can drive the changeover reduction forward. So like a 2-day Kaizen Blitz workshop where you do the measurements, you then go in and you do the analysis to understand where the wastes are. Then you're able to put some improvements in place, and then you're able, most importantly, to put the control system in place. And I think this is probably one of the bigger gaps with changeovers, is that's that control phase where we're measuring the standard. So if we've agreed a standard to say the changeovers went from 24 minutes to 10 minutes, okay, you're allowed a wee bit of variation in there, but you're checking that every single day to make sure that you're within those parameters. And that's traditionally done at a daily morning meeting. And we would have that as part of the implementation plan after that 2-day event. So 2-day event to me is the best way to go about it. Short, sharp, and quick.
Okay, great. Our next question is, what do you see the biggest issue with changeovers in the sectors you work?
Yeah, it's clear. I'm sure everybody on the line will say the same thing. Changeovers without clear standards. So if you don't have a standard that you're holding yourself accountable for, it's going to drive a massive amount of variation into that task. You'll have different people in different shifts doing changeovers in different ways, and the end result is obviously greater time, quality issues, and generally inconsistencies in the way changeovers are being done. So no standards is, to me, the number one.
Okay, our next question has just come in. Do you use a simulation to train teams on SMED methodology?
Yeah, that's another good question. I like that one. Yeah, we purchased a system, the SMED Lean Simulation Kit from Lean Games back in 2014, I believe it was. It's obviously been in use now for 8 years. We do this on site with teams. So the aim there is to demonstrate the principles of SMED and practice the methodology through the simulation before you go out onto the shop floor, because it gives people a baseline understanding of what they're trying to achieve. It's based on a simulated machine. We've used it in a wide range of industries. We've done a lot with CNC machining. We've done it in packaging. We've done a lot in food, plastics, construction, just to name a few. So it's not just for engineering. We've used it in a wide range of sectors. I suppose the machine simulates mechanical, pneumatic, and color and software alterations. So it pulls in a few different things there. And also, first off, with quality inspection. So all the key principles are pulled in that simulation. So yeah, we do that, and we can do that on site with companies. If we do it as part of that a Kaizen Blitz, a two-day session, say for talk's sake, we would do the simulation, then we would spend the rest of that period of time out on the shop floor, moving through the phases, and ultimately standardizing and reducing the changeovers for that particular process or machine.
Okay, no problem. We've just got a question in just with regards how do we access the Operational Excellence support. Again, I would say contact the OpEx Query email on screen, or again, we have lots of case studies, tutorials on the Invest NI website. So Simon, I think that's all the questions addressed. Again, thank you. And again, if you'd like any further information, please contact the OpEx Query email at investni.com.
That's brilliant, Kathy. Thank you very much.
Thank you, Simon. Thank you.